the session coordinator, chair, as well as co-chair for being on time and starting the session and introducing me as well. I also extend my thanks to IGC 2021 for giving me this opportunity to share my experience on this platform. So without wasting much time, I'll go ahead with today's theme lecture. So the topic is cause of slope failure and mitigation measures that were adopted. So this we'll discuss through two selected case studies. So going ahead, so this will be the contents of presentations, very brief, case study 1, 2, and then we'll directly go to the conclusion. So these two case studies, which I have picked here, are from two extremes of our, geographically, they are located two extremes, like part of our country. One is in the extreme west and one is towards the northeast. So let us see what are the conditions. When we talk of slope stability, as the topic says, so the topic of the presentation is cause of slope failure and mitigation measures that were adopted. So the more we talk about slope, especially slope failures, so it fascinates any civil engineer, I should say, not only geotech, especially for geotech, because each problem is different. The conditions are different, especially the soil strata that we'll be dealing is going to vary from site to site. So whenever we talk about slope, we are only going to learn further. So let's see what is there in case study 1 to study. So this case study we have I have picked from, as I said, from west region of our country, the famous landslide, or I shouldn't say famous, but it is a critical landslide that happened in the year 2020 in the region of Mumbai. The region again in Mumbai, it is in Malabar Hill area, a massive landslide occurred. And as it is from the south of Mumbai, the high-end area of Mumbai, there was this road on which the landslide occurred. Okay, it was a link road to various other areas of the city. So the ridge road, okay, that is there. That is one road that is above the landslide area. Okay, it's again a winding road, we can say. There is a road above the area where the landslide has occurred. It sunk to 6 feet, led to massive traffic jam. Okay, because as I said, it's a link road. It led to a lot of traffic jams. Roads. This road was leading to areas where a lot of our VIPs reside. Precisely, CM's bungalow, our governor's bungalow, and other VIP offices are also located in and around this area. So what does this call for? This call for immediate action in form of investigation and the remedial steps that need to be adopted. All had to be taken on a war footing basis. So just to go ahead, I'll give you a glimpse of the landslide. We can see it occurred after a heavy rainfall, downpour, which has been happening for 3-4 days in that particular time frame, that is August 5th. And one morning the caving in happened. We can see the whole slope has come down on the road, and part of the road was closed, or for certain days even the road was completely closed, so causing a lot of hindrances. So this is the road which is above the landslide, which had huge cracks. Now what was the cause? When we talk of landslide, definitely we all come to a conclusion that the main culprit is generally water. And like any other slope, yes, here also the culprit was water. So how did the investigation and the remedial measures or the design aspect move ahead? There was a committee appointed by MMRDA, that is the end client, that is Mumbai Metropolitan Road Development Authority. They appointed a committee which had, of course, IIT Bombay. Then there were other consultants, investigation agencies were there, as well as the contractors were also part of this committee, who assessed the probable causes. And what did the investigation reveal? There was heavy accumulation of water in the backfill slope, development of heavy pore water pressure because of the accumulation of the water. This weakened the hill slope and the existing retaining wall. There was again a wall that was existing and which weakened. Ultimately, it affected the structural stability of the existing retaining wall, and the landslide occurred. Now, Coming back, was there no study conducted earlier, or did it come on one fine morning? No. So when we look in depth, definitely there was a audit that was carried out, because there were other reservoirs, small reservoirs, that were being constructed around that area, and the audit revealed that there was a need of slope stabilization, construction of the wall, as well as setting up of the in protection nets for the landslide. A tender was also called, but then it didn't happen. Ultimately, we had to suffer this landslide. This again is from the courtesy of the media. Now, what are the mitigation measures that were adopted after the analysis and considering there were some we couldn't go for a very stable slope, because there is a road that is connecting at the top of the slope as well as the bottom of the slope. So luxury of maintaining a gentle slope was not possible. So it was a necessity to construct or stabilize the slope within the area or within the space that was available. So retaining wall had to be constructed at the base of the slope. Space was limited, so we had to design accordingly. Then the existing slope had to be dressed for whatever height to reach the upper road as well. And it was also observed that from Cheney 90 onwards, there was steep slopes. The total road of the area that need to be treated was for a stretch length of about 250 meters. So at the base of the slope, we need to do a detailed analysis. So accordingly, the base was stabilized. On the surface of the slope beyond the wall, we had to adopt erosion control measure as well as stabilizing measure also. So erosion control mats were provided on the surface of the slope, which was again reinforced with steel mesh. The slope was strengthened with grouted nails, and subsurface drainage arrangements were provided. Okay, so who was that provided? Let us have a look at the photographs. So this was some of the glimpses of the analysis that were carried out. Investigation was done. So accordingly, water parameters, pore water pressure was considered in the backfill, and nails were designed. So we used the commercially available softwares. Now this was a typical cross section. I'm just taking one particular change. Of course, was changing as per the requirement along the stretch length. So we can see that the top of the slope was treated with erosion control mat, surface of the slope. Nails were driven, and pins were provided in between, and wall was provided at the base of the slope. Drainage arrangements, the blue color lines are indicating the pipes that were provided, drainage pipes. Perforated pipes were provided, which were again lined with a layer of geotextile. Now these water again had to be collected at particular location, had to be diverted. So these are the photographs of the site. This is the site before any treatment as it is when the landslide had occurred. So the work has started, the clearing up work, slope dressing, slope clearing activity. Now this is again driving of the nails. Now, how did we do the drainage arrangement? Drilling of boreholes. So the PVC pipe had to be perforated on the pipe surface at the site itself. Wrapping of geotextile around the perforated pipe. Installation of pipe on the drilled hole, and again we had to pack the face of the drilled hole so that there is no reverse movement of water. So these are the perforations, insertion. This is typical arrangement. Now this is the dressing of the slope, and erosion control mats are provided to prevent the surface failures or to take care of the local stability at the site. Then these were again reinforced with steel mesh, hexagonal wire steel mesh. And on the surface are the anchors that you can see that have been driven and then tightened with the base plate and nuts. Now this is the construction of the retaining wall simultaneously at the base of the slope. In the view from another angle. This is after the vegetation had started coming up at the site. This is a panoramic view of the area, wall, and then we have a slope At certain location, we had to provide flexible gabions at the base as well. Now, coming to this, so the slope was successfully restored. The incline was here, MCGM, as I said, and even MMRD was also involved. Then we have a design drawing was given by structural structural designers, soil nailing contractors supported by Engosym, and vetting and proof checking by IIT. And finally, it was the road was reopened 10 months after landslide. So this is first case study that we saw what were the causes and how it was addressed. Coming to the visible challenges in hill roads, as I said, so hill roads again calls for a collaborative work from different fields of civil engineering, not only geotechnical, even rock experts have to be involved. We need hydrological expert, hydraulic expert as well. So it comes as a collaborative work. So when we talk of visible challenges, the surface flow from the hillside is a typical image we can imagine. We have flow from the hillside, we have an embankment, and then which is followed by the valley side. And this is a typical again arrangement where we have to cut on the hillside and the same material because of logistics and again viability point of view or feasibility of the project point of view, we have to use the same cut material on the fill side, okay, to widen the existing embankment. Now coming to what are the mechanics of slope failure or how does it happen? There is again when we talk of hillside, it will be either the young Himalayas or we'll be having on the when we come to the west coast, we have the lateritic belts. And when we talk of again on the eastern coast, it has again fragile kind of strata. So natural terrain, climatic conditions, seismic coefficients, human intervention, all together form a conducive environment that leads to a highly unstable conditions in the valley and which leads to slope failures, which could be either at the toe or it could be a slope failure in general, or it could be a deep-seated failure, which we again address as global stability issues. Now, we have this wonderful guideline that is SP 106 2015, which gives about the landslide remedial measures. There are different ways in which we can address the issues related to landslide, which varies from modification of slope geometry, could be only drainage, retaining structures, or the internal slope reinforcement. And it also states about the different options and its implication. It could be either technical or cost implication point of view. Now, what are the slope requirement? The solution requirement in such condition predominantly? Of course, it is not applicable to each and every case, but let's try that if these are there, then the solution could be a comprehensive one. So we need to have a permeable and a free draining structure. Okay, because heavy surface runoff again has it adds to the subsurface saturation. So it is good to have a permeable and free draining structure, environmental friendly, flexible, and the speed of construction has to be good. Cost of construction obviously has to be optimized, and let us try to use locally available material as much as possible. And foundation consideration, as we are already working in hill roads, so the necessity is we need to have the foundation consideration should be such that the excavation should be as minimum as possible. Now these are some of the products which are invariably used. I'm not going in detail, but yes, gabions, reinforced soil system, geogrids, flexible anchors, erosion control measures, geotextile. So now taking ahead with the going ahead with the presentation, let us look at case study 2. So as I said, case study 1 was for the was from the west region. Now case study 2 is going for the extreme east side, or you can say even the northeast state of Mizoram. So what we did there, what was the condition and what was adopted there. So here, so this is a typical case of Dimagiri area, TK road, internal road, maintained by Public Works Department. So if you see in this particular image, at the top, you can see certain structures. Top of the hill slope, there are certain existing hill structures are there. And already there were some measures that were being carried out at the base of the slope. So initially the department constructed rigid retaining walls. Further, they felt that these small toe walls at the base is not sufficient, then they extended it further by constructing 2 or 3 layer flexible gabion retaining wall. Still, the stability issues were not getting addressed, though it was after looking at the site, looking at the parameters, we did the investigation at the site, looking at the parameters of the fill material that is on the slope. We found that it was more of a local failure, or the surface failure, the surface failure that was happening. And it was not possible to dress the slope at a gentle inclination because the structure at the top is of a graveyard. So it was at this chainage, as I said, the slope failed during previous monsoon. Graveyard at the top of the slope posed challenge. So because of that, we had to deal with whatever space was available. So these walls were already constructed at the base. There was no point of removing these walls because they were serving the purpose of toe stabilization. So what could be done with the limited space at the toe, and we have the issues of rainfall. So we adopted this measure of taking care of the surface stability with the help of turf reinforcement mat that was draped on the surface of the slope. Now this again, along with this turf reinforcement mat, okay, we had driven terralock anchors. These terralock anchors are flexible anchors which can be driven to a certain depth based on the requirement of the stability of the slope. Okay, these were designed, and then the space in between the anchors were driven with stabilized with pins. So we use this system. So for a better understanding, so I'm just showing a closer view of the anchors and the helical pins that were driven in conjunction with the anchors. So a typical cross section, as I mentioned, it was more of taking care of the surface stability of the slope and to ensure that the surface is not exposed to continuous weathering. So there was the existing toe wall is being is maintained as it is. The surface was draped with the mat, and then anchors were driven to capture the surfacial sliding failure and absorb erosion, the erosive forces.
3 minutes more.
Yes, sir. It will be wind up. So these are some of the images during installation. So you can see the closer view. So again, here the end client was the PIU unit, that is the project implementation unit, PWD Mizoram. The design, drawing, and estimation was given by Gripple. Approving consultants were Shilladia and executed by local contractors. Now this is the image of the current site, or you can see how the current site is. Of course, it is not a very nice or very disciplined vegetation, but yes, the slope is stabilized. Now, this is the concluding slide. We can see that ecological disturbance we also observe has an adverse effect. But at the same time, we also get warning signs, okay, especially in case of slopes. In case of huge slopes, it may not be there. But when we are doing certain study, if we get some warning signs, that needs to be taken up seriously. Initial stage of the project, that is DPR, which consists of study, risk analysis, as well as a financial guide that is given by the DPR. The working out of the DPR itself needs to be given, its due diligence. This can take care of a lot of problems related to slopes at a later date. Quality and optimization, definitely, when we talk together, the terms quality and optimization, it's a challenge, but yet achievable if the steps or the above steps are taken seriously. Adopt advanced technology and take benefit of the technically superior solutions. So this is about the the case studies we saw. How we took first case study, it was more of a combination of the conventional and the innovative solution. But the second solution, where it was necessary to contain the slope in the given the space available, we had to go for innovative solution. So we have to adopt the advanced technology as well. So these are some of the guidelines and codes which give solutions or gives guidelines with the emerging technologies, so that can be adopted. So that's it about the presentation, sir. And for any queries, I'm ready.
Yeah, thank you, Ms. Iyer. Very nice presentation, and I can see some questions in the chat box. Mr. Rajaraman has asked, what is this erosion control mat made up of? I hope you can see it in the chat. Yeah.
So here, see, erosion control mat, if we look at the MORTH guideline, there are elaborate specifications that are given. But here in this case, what we used is a combination of PP mat as well as combined mat, so that PP gives the strength and longevity, and the coir ensures that the moisture is withheld in the mat and vegetation comes up.
Okay, and there is another query by him. Drainage holes efficiency considered in the design mandate, in the design?
Yeah, it was taken. So we had taken the while design itself, we had taken that the number of holes or the drainage that was considered in the input itself.
Oh, hello.
They can. I can give in detail if you want. We can discuss on how we incorporated in the design.
May I come in here, ma'am?
Yeah, Dr. Muthukumar.
Yes, sir.
Yeah, who is speaking?
Sir Rajaraman.
Okay, Rajaraman. Okay, one or two questions. Yeah, because we have.
Good afternoon, sir. Good afternoon, everyone.
Yeah.
So actually, this is about the drainage holes. As per our RDSO standards, we have to consider 75%. We have to consider drainage holes will be clogged for 75%. Only 25% is to be considered for design. So this you have considered in your design, and how did you consider this in design? Can you please elaborate on this?
Yeah, we can maybe if you can come offline, we can discuss on how we have taken it in the software itself. I can show it to you.
Yeah,
okay.
I think that would be nice. And there is one more question. I think Ms. Iyer, can you quickly 1 minute? Can you comment on the suitability of selection of remedial measures based on the lithology? In fact, this question was also there in my mind, and also the soil type of the site he is asking, Mr. Dinesh is asking. In addition, just one more query you can answer, then we will close this if Dr. Muthukumar allows us. That what were the initial investigations you took up for both the sites? Yeah, these are the.
Yes. Okay, so the routine investigation, geotechnical investigation was carried out for both the sites. Okay, especially for the first one, a very elaborate was done because, as I said, it was a VIP project with VIP people around. So we did the test, the triaxial shear test were carried out. So samples were collected. So a normal routine geotechnical test were carried out for the filled-up strata as well as the foundation strata.
Can you comment on his query? Mr. Dinesh has asked you. Can you comment on the suitability of selection of remedial measures based on lithology?
Based on? Sorry, sir?
Based on lithology.
Okay. I can come back because it cannot be answered in quick, in suitability of remedial measure. It needs to be done based on, again, if you see in both the cases, okay, we need to select the solution based on the conditions of the site, isn't it? So what are the limitations there? So all these need to be considered, as well as the suitability of the execution aspect also point of view.